Hey guys, so today we're gonna do 206 reverse linked list. So given the head of a singly linked list, reverse the list and return the reverse list. So example 1, we have 1, 2, 3, 4, 5, and we're supposed to reverse it into 5, 4, 3, 2, 1. Second example is the same thing, so it goes from 1 to 2, 1, 1, 2 to 2, 1. And then example 3 means that if we have an empty array, we should return an empty array. So what they really mean is if the head is null, then we return null. So we have two approaches here. We can do it iteratively and recursively. So in this case, we're going to do the iterative approach where we have better space complexity. So space complexity will be constant, so O of 1. So time will be O of n, and then space will be O of 1 with the iterative approach, as opposed to the recursive approach where we would be using the stack for recursion, and it would be O of n for space. Okay, so let's start by writing our edge case. And we're just going to say if the head is null, then we return null. And we are going to have two variables. So one is cur, and which is going to be the current node. We're going to start with the head, and then the previous node, which we start by making a null. And then in the end, we return the previous node, which is prev. So we return prev because prev will be the last node. So in the first example where it's 1, 2, 3, 4, 5, we're going to return 5 because 5 will be pointing to 4, which will be pointing to 3, which will be pointing to 2, which will be pointing to 1. So we return the last node, which would then be pointing to all the previous nodes. So now all we have to do is just change the pointers. So we're going to do that by looping through the linked list, and we're going to use a while loop that's going to loop up until we reach null. So null is when we exit the linked list, when we don't have any current node. Okay, so we're just going to say, we're going to create a temporary variable where we're going to make it equal to the current.next, which in this case would be 2, right? So it would be the second node, which is 2. And then we're going to say current.next equals to prev. So now we're pointing to so current.next is going to be pointing to prev, which is null. So now we just need to say what prev is. Prev equals to the current node, which in this case is 1. And then lastly, the current node equals to temp. So this is pretty much the whole problem. And all I'm going to do is just try to explain to you guys how the pointers are working. I suggest that you guys try to draw it in the interview or use your debugger while you're practicing. I think it's going to help you visualize what's going on, but I'll try my best to explain. So we have 1, 2, I'll just try the first example. So we have our first 5 nodes. So I'm going to call C as the current node, Cn as the current.next. We have 2 more pointers. We need T, which is temp, and I'm going to call P as previous, right? The prev. So prev is going to be P. So we know that temp is current.next, right? So temp is 2. Current.next is also 2. We know that current.next equals to prev, line 31. So we're going to say current.next equals to prev. Line 33, prev equals to current. So prev is now going to be equal to 1. And then lastly, current equals to temp. So we're just going to change the pointer now. So the current node is now 2. Oops, current.next is actually equal to prev. Yeah, okay. So current equals to 2. Current.next is now 1, which is also the previous node. And t, which is the temp, equals to 2, which is the current node, right? Current node equals to temp. And then we keep doing this until we reach null. So so after this, it would be like this and so forth. Okay. Hope you guys understand. Let's run the code. Okay. It was accepted. Let's submit it. Cool. Perfect. Hope you guys like it. If you have any questions, please leave a comment. If you want me to do any other problems, let me know in the comments below. And like and subscribe for any future JavaScript videos.